Hello everyone. Our project is Tiny ImageNet Challenge, a combinational approach. So first, I'll have a brief introduction about the Tiny ImageNet Challenge. And since Tiny ImageNet Challenge is a default project for Stanford's course CS231, so we'll display some previous best results in that course. And then we'll talk about the network architecture in our project, which is a combination between the ResNet 18 and the Inception v3. And we'll see the validation accuracy improvement that is got from this, that is achieved by this combinational network. And then we'll discuss about what makes the reasons that made this improvement by some experiments. So Tiny ImageNet is a version of ImageNet dataset downsampled to 64 times 64 pixels, and it has 200 classes. The task is that for each given input, the network should be able to predict which class it belongs to. So here are some previous best results in CS231. The leaderboard records the best test accuracy that has been achieved in this course, and we take the top 3 persons. The first one, we didn't find his report online, so we don't know the validation accuracy of his model. So we only know the test accuracy of his model, which is 73.2%. And the second person, Milani, his model achieves validation. He uses transfer learning to train an Inception v3 network and achieved validation accuracy of 76.7% and a test accuracy of 69.1%. And the third person, Kim, he also used transfer learning on a ResNet 18 network and achieved 75.01% of validation accuracy and 68.9% of test accuracy. So in our project, we first try to use similar approaches to reproduce the results that Milani and Kim achieved. So we also used transfer learning to train an Inception v3 network and a ResNet 18 network. And we achieved 76.6% for the of validation accuracy for the Inception v3 network and 73.12% of validation accuracy for the ResNet 18 network. As we can see that it's similar to that has been achieved by the previous person, but it's slightly lower. What we did different is that we combined these two networks, during the validation phase. And after the combination, the validation accuracy increased a lot. It increases almost 30%, and the validation accuracy is 87.69%. So it's a big improvement. The reason that we don't have test accuracy is because there is no correct answers for the test images in the Tiny ImageNet dataset. The way that we can get this test accuracy is to submit our result to the CS231's course website, and it will give us the test accuracy. But since we're not Stanford University students, so we cannot do that. So all the comparisons in this presentation, in this project, will be based on validation accuracy. Also, we should notice that this 87% of validation accuracy exceeded the previous results for big amount. We are actually inspired by the Milani, the second person here. He claimed that by ensembling several snapshots of InceptionNet, the validation accuracy improved to some extent. So we want to apply a similar approach, but the difference is that instead of ensembling several snapshots of a same network, we are ensembling different networks, which is ResNet 18 and Inception v3, which we have trained before. So these two networks have been trained independently beforehand, and during the validation phase, they are combined together to make the prediction. So the input will be fed into both of the networks, and we'll apply a softmax function to the output of the two networks, and then we'll get a probability array for each class. Then we'll add up the two arrays, probability arrays, element-wise, and we'll get a new probability for each class. Then we'll pick the class with the maximum probability as a final prediction. Although the two networks used only have validation accuracy around 74%, but after this combination, the validation accuracy of this whole combinational neural network increased a lot. It increased to 87.69%. So we will want to have a closer look at what makes such improvement happens. We would like to ask two questions. First one is that why different models converge to similar validation accuracy. As we can see that ResNet 18 and Inception V3, they are quite different models, but both of them converges to similar validation accuracy. So is that because of the constraint of training dataset? Is that because, for example, the resolution of the images are low, so even though the capacity, the ability of the network increases, but the validation accuracy will not increase because as the dataset may have set an upper limit for the test accuracy. And the second question is that since Inception and ResNet have different architectures, do they have different strengths in identifying images of different categories? Are they good at identifying different classes? We would like to know. So instead of just calculating an overall validation accuracy, we would like to calculate the accuracy on a per category basis. Here is the result. So the x-axis of this graph is a category index ranging from 1 to 200, and the y-axis is the validation accuracy for each category. The blue line is a result for ResNet 18, and the red line is a result for Inception V3. As we can see that the pattern is quite similar, that they are both good at identifying some categories. They both have high accuracy in identifying, for example, this category, and they both performed bad at when identifying this category. So maybe the graph tells us that some categories are by nature more difficult to identify, and maybe the quality of the data set of different categories are different. So this makes that different networks have similar pattern. But as we can see that the blue line and the red line, they're not exactly the same. Still, they have different strengths on different categories. So we would still give it a try, and we want to combine the two networks to see if we can get some improvement. And here is the result. The blue line is a combined accuracy for each category, and the red line is just that accuracy for the Inception net. You can see that there is an overall improvement, and it improved to 87%. So in order to further attest that this improvement is due to that different networks have different strengths, we would like to do another experiment where we select two snapshots of Inception V3 with validation accuracy of 73.22% and 76.6% respectively. So if we only see the overall validation accuracy, the two experiments have the same situation. But the only difference is that in the first experiment, we are ensembling two different networks, and in the second experiment, we are ensembling the same kind of network. And there's also an big increase in the overall validation accuracy, but this validation accuracy is lower than the previous one. So this tells us that ResNet 18 and Inception V3, they have different architectures, and they do have different strength. Yeah, so what inspires us is that maybe in some other scenarios we can combine different networks, different architectures. We can use their different strengths and to achieve better performance. That's all.